And we continue talking about various problems that may arise during your economic analysis. And today's problem is called heteroscedasticity. So let's see what it is. So here on this slide you can see a quick overview of today's lecture. So we'll start with a quick introduction. I will explain what heteroscedasticity is. Then I will move to the part about its consequences. Then I will tell you how to detect it and obviously how to deal with it. So let's see what is heteroscedasticity. When we relax another assumption of the classical linear regression model, the problem of heteroscedasticity arises. So let's see what this assumption is. And it sounds the following: homoscedasticity, or constant variance of area term. The variance of the area term is the same regardless of the value of x. So, and here you can see the notation. So you can see the variance of the area term is equal to sigma squared, and it is constant, so it is the same for all the values of x. However, if we have heteroscedasticity, this condition is no longer met, and what we usually have is the following. So now the variance is equal to sigma I squared, and this I represents the fact that sigma will be different for each observation. And let's see how it looks on the graphically. So when we have homoscedastic area terms or disturbances, this is how the density function looks like. If you look at those distribution graphs, you will see that they are exactly the same. So for all the values of x, for all the values of income, the distribution of the area terms is the same, right? It is equal. However, when it comes to heteroscedastic disturbances, this is no longer true. And if you look at this function, you will see that if you look at this graph, you will see that the density function is no longer the same. So for example, this variance, right, is higher, but it is more narrow. In this case, this distribution looks more like the one from the previous case, and in this case the distribution is wider. So what you actually see here is that on this graph is that area terms, they're becoming more spread out, so they are more and more away from each other. So in this case they're closer to each other, in this case they get a bit far away from each other, and in this case they're very, very far away from each other. So as you can see, for each value of income, the area terms become more spread out. While in this case, no matter what is the value of income, the spread out is the same for each observation. In this case, the spread out of the area terms, how far away they are from each other, is different for different value of x.